In the previous video, we looked at how constant multiplicative factors are really just another way of saying ratio. If something is a multiplicative factor of something else, it's in a ratio with it. We're now going to look at extending our language to include the idea of proportionality. But again, it's just going to work down to being a ratio. Because if A is proportional to B, A is in ratio to B. So let's look at an example. Suppose we have that 5 cinema tickets cost £55. How much does 15 tickets cost? Well, we know that 5 is proportional to £55. That's the information we're given. But proportionality is just another way of saying that they're in ratio. So 5 is in ratio to 55. Now, how do we get, on the left-hand side here, we have the number of tickets. On the right-hand side, we have price. How do we get to 15 tickets? Well, we have 5 tickets is £55, so we multiply both sides by 3. And we get that 15 tickets is £165. Okay, that's an easy example because everything worked out nicely. But we can have the same proportion, but make the problem harder. So let's say we have 4 cinema tickets, and they cost £44. Now how much does 15 tickets cost? Because our proportionality ratio is 4 to 44, where 4 tickets is proportional to £44. How do we get to 15? Well, we have to get the left-hand side to be 15. How do we do that? We divide both sides by 4 and then multiply by 15. We could do it in 2 steps, but let's just do it in 1. We have to multiply both sides by 15 over 4. The left-hand side will be 15 because we're looking at 15 tickets, and the right-hand side will be, as exactly as we saw, 165. So it doesn't matter that we've changed the number of tickets and the price, we've maintained the same proportion, and therefore we get out the same answer. Doesn't matter if it's an easy calculation, where we're looking at the number of 5s in 15, or where it's a harder calculation, where we're looking at the number of 4s in 15. We still get back to the idea that 15 tickets will cost £165. Suppose we have a bread recipe, and the bread recipe tells us to mix the flour, the water, and the yeast in a proportion of 6 to 3 to 1, which is just a ratio of 6 to 3 to 1 of flour, water to yeast. What proportion of that bread is flour? What proportion of the bread is water? What proportion of the bread is then yeast? Well, for that, we're going to need fractions. So how do we convert a set of ratios into fractions? Well, we consider flour first. So the proportion of flour will be 6 over 6 plus 3 plus 1. That's 6 over 10, which you may know as a decimal is 0.6. So 6/10 or 0.6 of the bread is flour. How much is water? Well, that's 3 over 6 plus 3 plus 1. That's 3/10 or 0.3 is a decimal. Finally, how much of the bread is yeast? That's 1 over 6 plus 3 plus 1. That's 1/10 or 0.1. And again, a good way to check that this is done correctly is that you add up all the different fractions or decimals and you ensure that it adds up to 1. Because as you split your bread into water, flour and yeast, all of it should be accounted for somewhere. So 0.6 plus 0.3 plus 0.1 equals 1. 6 plus 3 plus 1 equals 10, and so 10/10 is 1. So in all cases, we've been able to find out what the proportion of the bread is in terms of the flour, the water, and the yeast by using both ratios and fractions. Let's take a look at one more example, which is going to combine a number of different ratios and money. So it's going to be a bit more complicated. So I'm going shopping, and I have a shopping list of the following items. I need 12 cans of beans, I need 5 bottles of milk, and I need 20 potatoes. I have no idea what I'm cooking, but it sounds like good fun. So 12 cans of beans, 5 bottles of milk, 20 potatoes. And as I go to the shop, a number of these things are on offer. So I see an offer for 4 cans of beans at £2.20. I see that 3 bottles of milk is on offer for £3.51. And finally, the potatoes are 50 pence each. How much is my shopping grocery list going to cost me? Well, in all of these, I first turn my offers into ratios. So what I want to do now is get them all in terms of 1 to something, because if I can do that, then I can work out the total cost of each of the items. So for 4 is proportional to 220. I divide both sides by 4, and so we get 1 to 55. In terms of the milk, we have that we divide both sides by 3, and we get 1 to 117. And the potatoes are already in the form of 1 to something, so that's 1 to 50. What these is telling us is the individual cost of each item. So in terms of the bean, 1 can is 55 pence. Each bottle of milk is £1.17 or 117 pence, and each potato is then 50. So based on these simplified ratios, I can then work out the entire cost of my shopping list. Because 12 cans of beans means I multiply both sides by 12. So 12 cans of beans will cost 660 pence. 5 bottles of milk will cost 585 pence. And 20 potatoes will cost 1,000 pence. So 660 plus 585 plus 1,000 adds up to 2,245 pence. There's 100 pence to a pound, so dividing the 2,245 by 100, we get that that's equivalent to £22.45. In this video, we've been looking at proportionality, specifically direct proportionality, such that whenever we've multiplied one thing by a factor, we multiply both things by the same factor. So if you multiply the price by 10, you can buy 10 times as much that you're buying. There's also a different case called inverse proportionality, and that's where if you multiply one of your factors, you divide the other one. When does this occur? Well, the idea here is that if you, let's say, did some work, you're digging a hole, and you increase the number of people digging the hole, you will decrease the time it takes. So if you multiply the number of people digging by 2, hopefully you'll divide the number of time it will take to dig the hole by 2. So that's an inverse proportionality. We'll talk about this in a different set of videos later on. But overall, what I hope you've seen is that whether we're talking about proportionality or multiplicative constants or ratios or fractions, they're different ways of saying the same thing. And if you can get strong at doing one of them, you can then convert that skill to all the rest. In the next video, we're going to look at one final way, that of using graphs. Again, it's just a different way of seeing the same mathematics.